Our third application of order of operations is to use the annuity formula. Annuities describe many of our retirement accounts. Instead of depositing one sum like we might in a certificate of deposit at the bank, payments are made. For me personally, I contribute to my retirement account with each paycheck. So I make 26 payments per year because I get paid every 2 weeks. So we're going to take a look at a formula, and again, if you're asked to do this on the quiz, you will be given the information in this top box with the formula and the details of what each value stands for. So as we read our problem, quarterly deposits of $500 are made for 20 years into an annuity that pays 8% compounded quarterly. The first question that we're asked is, what is the value of I? Reading from above, I is the rate per period. So when I read this problem, the rate The rate is equal to the 8%. As we learned in our previous examples, we need to divide that by 100 to change it into a decimal. So our rate is really 0.08. Now, in this problem, it is that we're not figuring out R, but I. And I is defined to be per, which we know is divide, and period. So for this problem, it is quarterly. As we learned before, quarterly would be 4 times a year. So what we're going to do is we're going to take our R value of 0.08 and divide that by 4, and that will give us 0.02. You're welcome to use a calculator for that, and that is our I value. Next thing it asks us is, what is the value of N? We had this in the previous problems as well. N is the total number of periods or payments. So here we see that there are quarterly deposits for 20 years. So quarterly we know is 4. So we have 4 per year. And we're doing that for 20 years. So 4 times 20 gives us 80 as the N value. Then we're asked, what is the future value of this annuity? So I'm going to use the formula up here that starts with FV for future value and substitute in the values that we have. So the future value is equal to our payment, which is $500. And then the top of the fraction, we have 1 plus I, and we found I to be 0.02. And that is to the nth power, which we found to be 80. And then we have a subtract 1. That whole thing is divided by I, which is 0.02. So now we want to look at putting this into our calculator. We have to follow order of operations, which says start inside the parentheses. So in the parentheses, I have 1 plus 0.02. And I'm going to hit enter. I'm going to use my caret key to take that to the 80th power and enter. And I'm going to subtract 1. Enter. So that whole part is the top of my fraction, and that is grouped by the fraction bar. So now I can do my multiplication and division, which are at the same step. So I'll take this and divide it by 0.02 to finish my fraction. Hit enter. And I will take that answer times my 500 to finish the problem. Enter. So the future value of this annuity is $96,885.98. So $96,885.98. It's pretty good. So now the last question we have is, how much of that value is interest? We have a little bit more work to do than we did in previous problems, because I can't just subtract out 500. 500 was only one payment. So to figure out how much I paid in, we had calculated N was 80 payments or periods. So I'm going to take 500 each payment times the 80 payments that were made over the life of this annuity, and I do that math, and again you're welcome to use a calculator. I get $40,000 was paid in. So I'll take the total amount of the annuity and subtract the amount that we contributed, the $40,000. And that leaves me with $56,885.98. Still pretty amazing. We more than doubled our contributions over the course of the 20 years. So as life application, once you get out of college and get a job, make sure you start saving for retirement. The 20 years really makes a difference in this problem, and it allows us to build up that interest and have a nice amount in the annuity.